Alright folks, welcome to Chapter 2, Section 1, Scatterplots. Chapter 2 is really one topic. Section 1 happens to be the first step in the topic of linear regression. What we want to do is establish or try and see if there is a linear relationship between two variables. And Section 1 is really the first step in this process. And that's how Chapter 2 is arranged. And so now we're ready to look at scatter plots. Again, remember back in Chapter 1 when we first gathered data, what was the first thing we did? Well, we organized it, summarized it. And that's what we're going to do again. And so the first step is to create a graph. And the graph we're going to look at, it's called the scatter plot. The scatter plot is just the XY coordinate system you experienced in algebra. The only difference right now is that in algebra, everything was deterministic. You entered an X value, did some calculation, and out came out the Y variable. Here we're getting it from data, and we realize there should be some type of strong association, or at least we're hoping there's a strong association, but it's not going to be perfect. So the ordered pairs are going to look like, well, a scattering of points. And here's the rectangular coordinate system. You notice I've only included the first quadrant right now. I'm just going to assume that my both X and Y variables are positive, so I'll need the first quadrant. You'll notice that I'm calling the X variable the explanatory variable. I'm calling the Y variable the response variable. The reason for this is that the way we're going to think about it, Y is the variable we're interested in knowing more about. That's the variable we really want to explore further. What about the X variable? The X variable is another variable that we're going to try and associate with the Y variable in the hopes of doing what? Better understand the Y variable. One other way of looking at it, sometimes the Y variable itself, whatever this measures, it's not quite maybe easy to measure, not as accessible. Another hope is that by knowing this other variable X, which is easier to access, it will help us predict potentially what the value of Y is to some degree that we feel is informative. So this becomes our response variable, Y. Sometimes I like to call this the variable of interest. It's the variable that we're really interested in knowing more about. So now I collect my first data value, and again, it's going to be an ordered pair, one for the X, one for the Y, and there's my first value. Now let's say that I collect another data value, and this is the result of that. I'm going to put it here, and then I collect again. I collect again. Let's say now this ordered pair appears here. I collect again, graph my ordered pair, say it comes here, do it again. Get another order paired here, get another order pair, let's say right here, and so on. And you can again see that the order pairs are not appearing in a perfect pattern, but I can see right now that as X increases, what's happening to the variable Y, the response variable Y? Well, here's a key word. It seems to be that Y is increasing on average, and that is the key word here, on average. So when I take my first order pair, that produced an X value and a Y value. When I increased X, the Y value jumped. When I increased X again, the Y value dropped. Increase X again, and I see it jumped, then increase down, increase up, increase a little more, up again, then down, then up. But you'll notice that the trend, overall trend, the average trend is to go up. Yes, individually I'll go up and down, but The trend seems to be indicating it's going up, and the trend seems to be following a straight line. So we think that this most likely will be a linear trend. So again, as x increases in value, y is also increasing in value, but on average. Furthermore, we could say that x and y are positively correlated or associated. The association is positive, all indicating that if I'm thinking of this as a linear trend, then I'm thinking about a line. A line has a positive slope in this scenario, so that's where the word, again, positive comes from. If I now rearrange my order pairs in this manner, let me just grab here and move them around a bit. Oh, I don't know. Let's say like this. Now, as x increases, what's happening to y on average? Y is decreasing on average. So again, now the relationship is negative, or there's a negative correlation, negative association. So again, for a negative correlation association, as x increases in value, y decreases on average. Another important topic, strength of an association. What do we mean by the strength of an association? An association between two variables is strong if the ordered pairs closely adhere to a particular pattern. And again, I want to remind you, not necessarily linear. So this is kind of a general idea. Consider these two graphs. Of the two, which one do you consider has a stronger, in this case, linear relationship? I think you would agree that this one right here is the one with a stronger linear relationship. Again, the ordered pairs are closely adhering to a linear trend. This is also adhering to a linear trend. As x increases, y increases, but the ordered pairs are further apart, so the association is not as strong. In other words, it's hard to see that linear trend in this one versus this other graph. Two other graphs. Which one would you consider has the stronger association? I think you would probably say the one here on the right has a stronger association. Again, I can see that it's definitely not linear. Maybe it's exponential. Who knows? But this one is certainly following a very close trend compared to this one. So we would say this one has a stronger association. Again, in this case, it's just not necessarily linear.